Okay, this is Unit 6 review. If you look at number 1, it says write an equation for the line that is parallel to the given line and passes through the given point. So over here on the Smart Notebook, I've made an equation, or there's an equation there and 2 points. What you first need to do is figure out what your m is, and your m is 5. And since it's parallel, you're going to use the same slope. And then for your point, you're going to use the 2, 16. So those are the two things you're going to use. You're then going to plug it into point slope form, which is y minus y1 equals m times x minus x1. You're going to plug in your information you know, which is y minus 16 equals 5 times x minus 2. That's in point slope form, and then you want to go ahead and get it down to slope intercept. So you need to distribute, and then you have 5x minus 10. One more step, you add 16, cross that out, and you get y equals 5x plus 6. That's the equation that's parallel to that through that given point. Okay, I'm going to do one from number 2, 3, and 4, and on those they say tell whether the lines for each pair of equations are parallel, perpendicular, or neither. And on number 2, you got one equation right here that has y by itself. You got the other one that's not, and that's the one you need to get y by itself to decide what the slope is. Because in the first one, the slope is negative 1 over 6, and you're going to compare the two slopes. So if I get y by itself by subtracting 24x from both sides to move it over, I get 4y equals negative 24x plus 12. You can't combine those. And then I need to divide by 4 from all sides, and you get y equals negative 6x plus 3. So that's my new equation. So this is the second equation in slope-intercept form. Now I want you to look at this slope, and if they're the same, they're parallel. If they are opposite reciprocals of each other, they're perpendicular. So negative 1/6 and, oh, wait a minute, I did something wrong. Big time. Oh, this is negative 4. Okay, guys, make sure you notice this. Watch what I'm doing. Okay, this is negative 4 right here. So then when you divide, you need to divide by negative 4 and negative 4 and negative 4. So this will actually be, I'm glad I did this actually, this will actually be negative 3. I rarely do that, I'm sorry. So this should actually be positive 6. So it should be y equals positive 6x. And so your slope is actually 6. So if you compare negative 1 over 6 and 6, those are opposite reciprocals of each other. So opposite means they're different signs. So one is negative, one's positive. Reciprocals means that it's upside down from the other. So that means that these are perpendicular lines. If they were the same, that means they'd be parallel. If they're not parallel or perpendicular, then they're neither. So that's where you have, like, number 3 ends up being neither because it's neither one. Number 4 ends up being parallel because they end up being the same slope. Number 5 works very similar to number 1, but a little bit more work. You have to write an equation of a line that's perpendicular to the given line and that passes through the given point. Well, first of all, the problem with this is I don't even have something that has y by itself. So I need to get y by itself first, and then I will have 3y equals negative x plus 16. And then I'm going to divide by 3 to everything, and I'll get y equals negative 1/3, because remember there's kind of an imaginary 1 here, x plus, that's about 5.3, but that won't even really matter in a second. So this is slope-intercept form for this one. And what you're going to do is you're going to look at this slope right here, the negative 1/3. And I need to have a slope perpendicular to this. So perpendicular slope is actually positive 3, because the opposite is positive, the reciprocal would be 3 over 1. So I'm going to use, for my m, I'm going to use 3. And for my point, my x1, y1, I'm going to use what I was given, negative 3, negative 4, and use the same process I did for number 1 from here on out. So I take all this information, bring it over here, do this in a different color. I'm going to do y minus y1 equals m times x minus x1. Plug in my information, which is y minus negative 4 equals m, which is 3, times x minus x1 is negative 3. And make the double negatives a positive, so y plus 4 equals 3 times x plus 3. Now I need to distribute, so boom, boom, distribute. Y plus 4 equals 3x plus 9. Last step, subtract 4, cancel, and I get y equals 3x plus 5. That's your equation that's perpendicular. Okay, I just want to talk through number 14. It says below are the graphs of y equals absolute value of x and y equals absolute value of x minus 9. How are they different? They're different because they have the exact same shape. They're a V shape. They're not increased by anything really. They have the exact same shape, only the y-intercept of one of them is 0 and the y-intercept of the other is negative 9. So in other words, one is simply shifted down. And that's really all you need to know for number 14 and 15. If you notice on number 15, it's actually shifted up to positive 11. That's it for that one. Okay, I'm going to do number 22, and then I'm actually going to do quickly 21. 22 is y equals x plus 5, and then also y equals negative 5x minus 1. You're looking for what is the intersection of the two. So we need to go ahead and graph it. So where you see the plus 5, okay, I'm going to do this one first. Where you see the plus 5, that's the y-intercept. So it's up 1, 2, 3, 4, 5, right here. Okay, then I have a 1 in front. This is my slope. So it's up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And draw yourself as neat of a line as you can. I don't have specific graph paper on here. You guys can use a sheet of graph paper. And then for the other equation, which I will do in blue, y equals negative 5x minus 1, I'm starting right here. And I'm going, let's see, down 1, 2, 3, 4, 5 over 1. And then I can go in the other direction, 1, 2, 3, 4, 5 over 1. Looks like it's about at negative 1 where it crosses. And I can keep going. Draw yourself as straight of a line as you can. It's a little bit off. But you just graph two lines, and you're looking for that point where they cross. That point where they cross looks like it's at negative 1, comma 4. And that is your solution for that problem. Now 21 works the exact same way, except on 21, I won't graph the whole thing, but 21, the problem here, we've talked about this in class, is that you have equations that don't have y by itself. So for the first equation, I'll write them out both so you can have some room. For the first equation, I've got to add 4x to both sides before I can even graph this. And I get 3y equals 4x minus 12. And then I divide by 3. And then I get y equals 4/3 x minus 4. You can graph that. And then for the next one, I'm going to do the same kind of process. I'm moving my 2x over. And I get 3y equals 2x minus 18. And then I divide by 3 to everything. Divide by 3. And then I get y equals 2/3 x minus 6. And that's your equation for that. And then you would graph them and find exactly where they cross. And they happen to cross at negative 3, negative 8, if you graph them appropriately. Okay, for number 27, you have y equals negative 3x plus 2. So I'm going to go ahead and graph the plus 2 right here. I'll just do a quick sketch so you can see it. Down 3 over 1, down 3 over 1. Quick line, straight as you can. And then negative 3x plus 4, I'll do in red. The plus 4 would actually be farther up here, and you would actually follow the same exact slope in the same direction as you did before. What you should notice is not only does it look like they're going in the same direction that they won't touch, but they also have the same slope but different y-intercepts. When you have that, that means they're never going to touch. So never touch. So they never touch. So there is no solution. If they would, which I'll show you in a second, if they intersect or touch all the time, then they would be infinitely many solutions. So then on number 30, you have a set of two equations, same kind of deal as number 27. You have y equals negative 3x minus 4, and then you also have y plus 4 equals negative 3, and then kind of ugly x there. I apologize. What you need to do is get y by itself. Okay, if we don't have y by itself, make sure it happens, and then you'll get y equals negative 3x minus 4. So you have technically two different equations. You have this one that you didn't have to do anything to, and this one that you got because you knew you had to get y by itself. So if I have those two equations, if I graph the first one, and I'll just do a quick sketch on these, and I go down 3 over 1, down 3 over 1, I graph that line, I think you will find that if you graph the other equation, it will actually end up being on the same exact spot, same slope, same y-intercept, everything. So they always intersect, which means that they have infinitely many solutions. Okay, number 34 is, now we're getting into inequalities. So on number 34, you have y is less than 4x minus 1. So if I draw a quick sketch of a graph, and you start with the negative 1. My negative 1 is here. Remember, there are 3 steps when it comes to inequalities. The first step is to find out where the location of the line is. So I need to go up 1, 2, 3, 4, and over 1. Up 1, 2, 3, 4, over 1. Up 4 over 1, and keep going. So that's the location of the line. I'm not doing my line yet. Now, second step is you need to decide what kind of line. Remember that if you see a solid line underneath this inequality right here, then you're going to see a solid line in the graph. If you don't, like we do here, it's just a less than, it's not or equal to, you're simply going to do a dashed line, which means it does not include, the solution does not include that line. Now, I see less than. Okay, this is less than. And less than means below or upside down. When I say upside down, I mean on this side. If you had a stick figure on the one side, on that side, he would technically be upside down. And that is your solution. I'm going to do 36 in 2 phases. First of all, the problem with this is you don't have y by itself. So we need to get it in slope-intercept form by getting y by itself. I subtract 3x to both sides, and I get negative 7y is less than negative 3x minus 21. Sorry about the bell. And then you get divided by negative 7 on all sides. And I want to point something out to you guys that you may have forgotten. When you divide by a negative number in an inequality symbol, which is right here, what happens is that inequality symbol flips around. And then you get 3/7 x plus 3. So that's the inequality that you're going to use. Okay, now we're going to graph it. So what you have is you have 3/7 x plus 3. And I may have actually done this wrong in the answer key, but I want to make sure. Yeah, it should be plus 3 because you divided by a negative. So I start at plus 3. I then go up 1, 2, 3 over 7, which is quite a ways, and kind of go in that direction. And that's the location of the line. And then I decide what kind of line. It's going to be a dashed line. And then you have to decide, is it above or below, and it happens to be above. And so that's your solution. Everything above that, but not including it. Okay, real quick, y is less than negative 2. This is one that does not have a slope. It actually goes through at negative 2, and it is a horizontal flat line. But the problem here is that I did this so that it would be a actual line, but it shouldn't be an actual line. So I'm going to go ahead and try to take away some spots. Not perfect, but at least it'll tell you that it's a dotted line. So it's a dotted line, and then it should be everything below that. Well, that's your inequality graph. Okay, for number 43, the answer is displayed. Y is greater than 4x minus 3. Let me show you why. On 43, let me scroll down to it. Excuse me. On 43, you're starting at -3. That's where it crosses the y-axis. Then you're going up 4 and over 1 to the next point. That's how the 4x minus 3 comes from. Then you know it's there's no line underneath the inequality because it's a dashed line. And then you know it's a greater than because it's all shaded above. That's how you know. Okay, last one we're going to do, 46, is y is less than or equal to x minus 2, and y is less than or equal to -3x minus 6. That is the final answer. Let me show you why. So on number 46, the reason why it's y is less than or equal to x minus 2 is because on the first line, right here, the minus 2, you start with the minus 2, and then you go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, and that's your graph. Now it's a solid line underneath the inequality because it's a solid line in the graph. Then it's shaded below, so that's why it's less than. Now in the other one, it's -3x minus 6. It's minus 6 because you're starting here at -6 on the y-axis, and then you're going down 3 over 1, down 3 over 1, in the other order, okay, other direction. It's a solid line underneath the inequality because it's a solid line in the graph, and then it's below, so it's right here. So everything below that in that dark area is what the actual solution is, and so you should be writing two inequalities. Again, these are the answers right here. Okay, that's been Unit 6 video. Anything else that I did not cover, we're either going to be doing in class for sure, or is very, very obvious on the answer key, or we are not going to be doing on the test, which I'll talk more about in class.